Okay, here we have a couple good practice problems to go over before the test on section 6-1. And the first question, it says for the following angles: A, sketch the angle in standard position; B, determine the quadrant in which the angle lies; and C, determine one positive and one negative coterminal angle. Well, our first angle is 310, and here is our xy axes. We start at 0, and then every axis is 90 degrees, 90, 180, 270, and then back to a full circle is 360. This angle is 310. That lies here in between 270 and 360. So to sketch this angle, we're going to bring it around here down to the fourth quadrant and draw our angle right about there, 310 degrees. So that's part A, sketch it in standard position. Part B, determine the quadrant, and I already said down here we're in quadrant 4. Remember, upper right is 1, and we go counterclockwise, 1, 2, 3, and 4. So we're in quadrant 4. In part C, we want a positive and a negative coterminal angle. So we were given 310. Let's find the positive one first. You know that what they mean by a coterminal angle is an angle that begins and ends on the same initial side and terminal side. So here we did half or almost a lap around the circle here to 310. Let's just add another lap to it. Let's go around the circle one more time. So we started with a 310 degree angle, and we're going to add another circle to it, 360. So our positive coterminal angle is going to be 670 degrees. For our negative coterminal, we're just going to subtract 360 from 310. In a circle, there's only 360 degrees to go around. We've already used 310 of those degrees up. If we subtract a circle from the 310, we get negative 50. And remember, negative angles are the ones we measure clockwise. So we're starting here at the initial side. Oops. We're starting here at the initial side, and we're going in the negative angle direction until we hit this terminal side, negative 50. So that was question 1, which was in degrees. Question 2 is the same type of question, but now we're dealing with radian measure. So for radian measure, we start at 0, and every 90 degree angle or every right angle is a half pi. So here we have a half pi radians, 1 pi radians, 3 halves pi radians, and then a full circle. We're back to 2 pi. Now this is an improper fraction. I like to convert those to a mixed number. It makes it easier to see it when I'm sketching it. So if I convert that into a mixed number, 3 divides into 4 one time with 1 left over. So 1 time with 1 left over out of 3, negative 1 1/3 pi. So to sketch the angle, I go here would be, that's right, it's negative. I got to go in the clockwise direction. So every right angle is a half pi. Here is negative 1/2 pi. Here's negative 1 pi. And somewhere in between negative pi and negative 3/2 pi will be negative 1 1/3. So somewhere up here. Negative 4/3 pi. So that was part A. Part B, what quadrant does that lie in? That is quadrant 2. And part C, a positive and negative coterminal angle. Since I was given a negative angle, I like to find the negative coterminal first. And we started with negative 4/3 pi. Well, to find another negative coterminal, we would just do another lap around the circle. In this direction, that would be another negative 2 pi radians. So what I can do is just take my negative 4/3 pi here and just put a 2 in front of it. And now I want to convert this to an improper fraction. 2 times 3 is 6, plus 4 is 10. 10/3 pi is our negative coterminal angle. And now for the positive. We're going to start here at the same initial side, but go in the positive direction until we hit that same terminal side. A circle has 2 pi radians to go around. So there's 2 pi radians. We've used up 1 1/3. You know, we're just ignoring the sign. So there are 2 pi radians to go around. We've already used up 1 1/3 of them. 2 minus 1 1/3 is 2/3. And we're talking in pi radians units. So our negative coterminal angle is negative 10/3 pi. Positive one is 2/3 pi. Question 3 and 4 are conversions. We're going to convert from degrees to radians and then radians back to degrees, and we'll sort of ignore this round to 3 decimal places here. All you have to remember for this conversion is two fractions, either pi over 180 or 180 over pi. We're going to multiply what we're given by one of these two fractions. And what we are given determines what fraction we will use, since this is degrees. We have 450 degrees. We're going to multiply it by the fraction with degrees in the denominator. This is pi radians over 180 degrees. So we're going to multiply the angle we were given by pi radians over 180 degrees. Now we can cancel here on the diagonal. These degree signs will cancel out. And then we can just multiply straight across. 450 pi radians divided by 180. Now, if we do 450 divided by 180, 450 divide 180, we get 2.5, and it's pi radians. So 2.5 pi radians. Or if we notice, we can see this here as a fraction, 450 over 180, cancel the zeros, and then this would reduce down to 5 halves. We could divide by 9. So 5 halves pi radians, or 2.5 pi radians. Now for the other direction, we are given radians. We want to convert to degrees. So this is 7 pi over 5 radians. We're going to multiply by the fraction with radians in the denominator, with the pi down here. So we're going to multiply by 180 over pi radians. And the radian measure cancels. The pi's cancel. And if we multiply straight across, 7 times 180 divided by 5. 7 times 180 is our numerator, equals, and divide that by 5. And we get 252 degrees. So 252 degrees is the same thing as 7/5 pi radians. 5 and 6 deal with complements and supplements. First, in degree mode. In degree mode, complements are two positive angles that add up to 90 degrees. Supplements are two positive angles that add up to 180. So we will take our given angles and subtract them from these numbers. So for part A, our given angle is 24. The complement is 90 minus 24, which is 66 degrees. For the supplements add up to 180. 180 minus the given 24 degree angle is 156. So there's the complements and supplements of part A. Part B is 126 degrees. So for the complement, 90 minus the given angle. Well, 90 minus 126 is definitely going to give us a negative angle. By definition, complements are two positive angles that add up to 90. So for this, there is no complement. But for supplement, we do 180 minus the given angle. 180 minus 126 is 54 degrees. Oops, equals 54. Now we're going to do the same thing, but in radian measure. So now that we're switching to radian, complements added up to 90 degrees, which is pi over 2 radians. Supplements were 180 degrees, and that in radians is pi. So for the complement, we are going to take pi over 2 and minus our given angle. Now we need a common denominator. We need to turn this into a 12, so I want to multiply by 6. I'll multiply the numerator by 6 and the denominator by 6. Common denominators there, so 6 minus 5, or 6 minus 1 is 5 pi over the common denominator 12. For the supplement, pi minus the given angle. Common denominator is 12. This is 1 pi, or 12/12 pi. 12 minus 1 is 11 pi over 12. 11/12 pi. The last one is about arc length. So it says find the length of the arc. Length of the arc means we are finding a chunk of the circumference of the circle. So on a circle with a radius 15 and a central angle of 120. So they're telling us the radius given is 15 and this angle is 120 degrees. The formula we need is S equals R times theta. S is the arc length, R is the radius, theta is the angle. This angle must be in radian measure. If you throw in degrees, it's not going to work. Radian measure. So this angle that we have, we cannot use. We have to convert it. 120 degrees times pi radians over 180 degrees. We're going to get 120 pi over 180. And reduce. The zeros cancel. Divide by 6. 2/3 pi. So instead of 120, we want to use 2/3 pi radians. So S, arc length, is equal to the radius 15 times 2/3 pi radians. Well, 15 times 2 is 30 over 3 pi. 30 divided by 3 is 10 pi. And since we're finding the length of an arc, let's get rid of that pi. If we multiply 10 times 3.14, we get 31.4, and our unit is inches. So this arc length that was cut out by a 120 degree angle has a length of 31.4 inches.